Okay, so we're going to start our discussion with the endocrine system. This is, again, Chapter 17. The endocrine system is a communication system, just like the nervous system or autonomic nervous system. It uses chemicals to send the communication. So it dumps chemicals into the blood, and the blood carries those chemicals or all around the body, and any cell in its wake that has a receptor for that chemical will be affected by it. So as a communication system, we know that we're going to start with a stimulus. So we know this from the nervous system. So we have a stimulus, and that stimulus is going to be picked up by a receptor. And that receptor, if the stimulus is strong enough, the receptor will send that input, so sensory input, like let's say a touch receptor or something like that. It's going to send sensory input down an afferent pathway. An afferent means sensory, and it's going to send it to an integrator. So that integrator is within the nervous system. There are also integrators in the endocrine system. And the integrator then is going to take that information, figure out what to do, and send output. And it's going to send it down an efferent pathway, which is motor, and it's going to send it to an effector. So an effector is whatever is going to do the action needed. So action or response. So that's how the nervous system works. That's also how the endocrine system works. The nervous system is a coordinating and integrating system that allows for communication. The endocrine system does exactly the same thing. So let's look at the nervous system versus the endocrine system. And let's compare the two. So okay, so let's look at some different things. So type of signal. In the nervous system, what is the type of signal? Well, in the nervous system, it's going to be an action potential, which is an electrical signal, or electrical type of signal. We're dealing with voltage-gated channels. Those are opening up and letting sodium in, and that signals voltage-gated potassium channels. They're opening up and letting potassium out, that type of thing. So it is electrical. But it is also chemical. And chemical in that it utilizes neurotransmitter, which is a chemical. So we have chemical signals too. So those chemical signals come from neurotransmitter that is secreted from the presynaptic membrane, crosses the synapse over to the postsynaptic membrane and binds to receptors in that membrane, allowing for the opening of channels and the movement of sodium and potassium. So in that way, we have both electrical and chemical signals in the nervous system. In the endocrine system, we have a chemical signal because we use a hormone. So hormone is just a chemical that is dumped in the blood. It's dumped in the blood and circulates throughout the blood, and any cell that contains a receptor for that chemical or hormone will be affected by that hormone. All right, so what about the targets? So in the nervous system, the target is specific. So you have an axon terminal that goes to something specific. Okay, so write that down, I guess. Axon terminal, which goes to something specific. In the endocrine system, the targets are general, because any cell that contains receptors for that hormone are going to be affected. All right, what about speed? So speed of transmission. So in the nervous system, it's pretty fast, right? It's almost instantaneous. So an action potential can travel about 100 meters per second. So it travels really fast. It's like instantaneous. In the endocrine system, it's slow. So it's slow because it basically takes about 1 minute for blood to circulate through the body, which isn't long, but in comparison to the nervous system, it is slow. All right. What about the effect speed? So speed of the effect. So in the nervous system, it's also fast. In fact, it's kind of immediate. So, you know, if a bug lands on your skin and you realize it, you're going to react to it immediately. Okay, you're going to see it immediately, and you're going to react to it just very, very quickly. In the endocrine system, again, slow. In fact, it's often delayed. So it takes a bit. It takes a bit for, you know, the chemical to go into the blood and to circulate through and to bind to the receptors and then to do whatever is going to happen within that cell. So what about duration, though, of the effect? Effect duration. So in the nervous system, pretty brief. Pretty quick there. In the endocrine system, pretty long lasting. The hormone is there, causes binds to the receptor. The receptor, opens the cell or does whatever it's supposed to do, causes whatever reaction within the cell, and it causes the effect to occur. I hope you can't hear my dog barking, but if you can, I apologize for that. I'm going to kill her. The intensity. So the intensity in the nervous system can only be increased when you increase action potentials. So if you want more effect, more action potentials are needed. In the endocrine system, more hormone. So we want to increase the effect, add more hormone to that. So that's the difference between the nervous and endocrine system. Both systems are integrators. Both systems are integrators. So you can see that here within the nervous system. And in the next video, we'll talk about how that is in the endocrine system, how it acts as an integrator.